Exercise 4. Distribution fitting. Imagine a commuter has provided a log of 25 previously recorded driving times. This information is located on the range examples B26 through B50. First of all, select the range of historical data to be fitted, B26, B50. Choose the distribution fitting fit command as shown. The following multi-tab window appears. The dataset specifies the source and type of input data entered, whether it represents a continuous or discrete distribution, and whether it should be filtered in any way. The first tab, the dataset options, specify the source and type of the data to be fitted. The options include name. Specifies a name for the fitted dataset. This will be the name shown in the Fit Manager and in any risk fit functions that link a distribution function to the results from a fit. Range. Specifies a range in Excel that contains the data to be fitted. Click on the second tab for the Distributions to Fit tab. The options on the Distributions to Fit tab let you select the probability distributions to include in a fit. These options can also be used to specify predefined distributions with preset parameters values to fit. Probability distributions to be included in a fit can also be selected by entering information on the lower and upper limits of these allowable distributions. By entering information on the lower and upper limits of the allowable distributions. Fitting method. The fitting method options control whether number 1, a group of distribution types will be fitted, or number 2, a set of predefined distributions will be used. The selection for fitting method determines the other options displayed in the Distributions to Fit tab. The fitting method options include parameter estimation. The procedure will find the parameters for the selected distribution types that best fit your dataset. Predefined distributions. The procedure will find the best fitted distribution from a set of distributions you predefine. Parameter estimation options. When parameter estimation is selected as the fitting method, the following options are available in the Distributions to Fit tab. List of distribution types. Checking or unchecking a specific distribution type includes or removes that type from the fit to be performed. The list of distribution types that are displayed changes depending on the options selected for lower limit and upper limit. By default, some distribution types in the list are unchecked. This is because, number 1, these types are specialized forms of an already checked distribution type. For example, an Erlang distribution is a gamma distribution with an integer shape parameter, and fitting them would be redundant. Or number 2, they are a distribution type not normally used in fitting, such as a student or a chi-square distribution. You can override at-risk's choice if you like. Lower limit and upper limit options include fixed bound off, which specifies a lower and/or upper limit. Only specific distribution types, such as triangular, have fixed lower and upper limits. So an entry for fixed bound will restrict the fit to certain types of distributions. Bounded but unknown specifies that the fitted distribution has a finite lower and/or upper limit, but you don't know its value. Open, extending to plus minus infinity, specifies that the fitted distribution can possibly extend to any possible positive or negative value. Unsure specifies that you're not sure about the possible values that could occur. At this point, we do not need to explore the third and fourth tabs of the fitting window, as they belong to advanced options not covered by beginner or intermediate usage of at-risk software. Click on the Fit button. An X value distribution will be chosen among the set of available distribution functions. If you were to use the default selecting criterion, which is Akaike Information Criterion, AIC. The AIC and BIC statistics are calculated from a log likelihood function. The AIC and BIC are clearly very similar. The theoretical underpinnings of both rely on Bayesian analysis, and the two different forms come from different assumptions for the Bayesian priors. The AIC tends to penalize the number of parameters less than the BIC. There has been much discussion in the literature about which one is more appropriate, and the jury appears to still be out. Palisade's recommendation is to use the AIC unless you have reasons to do otherwise. Change your rank by options to Anderson-Darling statistic. Observe how the fitting tool now chooses another distribution, the log logistic, as the best distribution according to AD. By clicking on the log logistic option, you will be able to see both overlaid curves as they are related to the original data set depicted by the blue histogram bars. By viewing the two curves and their slightly different suggested solutions, as well as the statistics on the right-hand side table, you will be able to compare how these distributions fit to your original data set. It has been demonstrated by empirical analysis that Anderson-Darling will do a good job for selecting distribution functions with good fits towards their tails. On the other hand, empirical analysis has demonstrated that Kolmogorov-Smirnov does a good job for fitting distributions towards its center. In this case, there is no ambiguity on the selection, since either under Anderson-Darling or Kolmogorov-Smirnov would select the log logistic distribution as the one with the best or smallest statistic. However, when there's ambiguity on the selection done either by an AD or KS goodness of fit test, you should question yourself whether you are more focused towards the tails or towards the center of the distribution. Since risk analysis is almost always focused towards the tails of the distribution, the AD method is usually favored in the case of ambiguity. Nevertheless, you should always consider the fact that either AD, KS, or the non-recommended simplified chi-square goodness of fit tests were never designed for comparison between distributions. The original intention of these three tests is for hypothesis testing on a one-by-one basis on whether the dataset being evaluated cannot be proved to belong to a certain distribution. This is the null hypothesis. That is the reason why at risk comes with a couple of other statistics, a Akaike information criterion, AIC, and Bayesian information criterion, BIC, that were actually and intentionally developed for comparing the validity of certain statistical models. The AIC and BIC statistics are calculated from a log likelihood function. Therefore, we almost always recommend to stick to AIC's recommendation, since both Akaike and Bayesian are statistics fully developed for comparing and ranking distribution functions. Make sure you're only selecting X value as the one distribution recommended on top by AIC. Click on Write to Cell. We will not change any parameters here. Just keep going to Next. Place the fitted distribution on cell B24 and click OK. Cell B24 shall now contain the following function: equals risk X value, open parenthesis, 60.6045, comma, 5.3668, comma, risk name, open parenthesis, double quotes, dataset 1, close quotes, close two parentheses. In order to view this distribution while keeping your cursor on cell B26, click on the Define Distributions icon to view its shape and statistics. As long as a cell previously contains a distribution, at-risk will retrieve its chart for editing purposes. Otherwise, if the cell is blank, at-risk will retrieve a palette in order to eventually place a newly created distribution function.